Oh, hey, didn't see you there. I'm Ben.
And I'm Nick, and today we will be demonstrating Charles' Law for you.
The materials we'll be using are a rope for measuring,
A ruler, a balloon,
and a freezer.
The equation for Charles' Law is volume 1 over temperature 1 equals volume 2 over temperature 2. In order to find the volume 1, we need to use the formula 4 over 3 times pi times the radius cubed. So that means we need to find the radius of this balloon.
To find the radius of the balloon, you go from the center out to one of the sides. We're then going to mark it and measure that on the ruler. And it appears that it comes out to 13.5 centimeters. As you can see.
Once we found the radius, we need to plug it into the volume formula, and when you plug 13.5 centimeters into the formula, you get the volume equals 10,306 milliliters.
We now need to find the inside temperature. The inside temperature is 75 degrees Fahrenheit, so we now need to convert that to degrees Celsius, and then later to Kelvin.
To find degrees Celsius from degrees Fahrenheit, we use the equation Fahrenheit minus 32 times 5 over 9 equals degrees Celsius. When we plug in 75 degrees Fahrenheit, which is the inside temperature, we get 23.888 degrees Celsius. We must now make that into Kelvin, so we take the temperature Celsius and add 273, and we get 297 Kelvin, and that's going to be our temperature 1. We also need to find the temperature 2, which is the temperature of the freezer that we put the balloon in. To find the temperature 2, we just look right here, and you can see that it's negative 17 degrees Celsius inside the freezer. We must now convert the temperature 2, which was negative 17 degrees Celsius, into Kelvin. So we add 273, and we get 256 Kelvin. Now that we know the volume 1, the temperature 1, and the temperature 2, we can plug it into the equation of Charles' Law so that we can find x, which is representing the volume 2, and the volume 2 is what the volume in the balloon should be after it's been in the freezer. When we plug in all the values that we know, we come out that x should be 8,883.2 milliliters once the balloon comes out of the freezer. Now it's time to put the balloon in the freezer.
The balloon is going to be in there for 30 minutes, starting now.
Oh no, that's the timer. We need to get it out. Now that the balloon has been sitting in the freezer, it should have shrunk. So in order to find out if it shrunk, we need to find the new volume. So we need to find the new radius. And I'll just mark it right there.
We'll then measure it, just as we did last time. And as you can see, it is roughly 12.7.
So now that we found the new radius, we can then plug it into the volume formula again. Once we plug in the numbers, we find out that the new volume of the balloon is 8,580.2 milliliters. You can see that the actual yield we got from the experiment is really close to the theoretical yield that we should have gotten in the experiment. So in order to find the percent yield, we take the actual yield and divide it by the theoretical yield and multiply it by 100. And we get a percent yield of 96.6%, which is very close. The reason that the balloon shrank in the freezer is because temperature is directly proportional to the speed of gas molecules.
So when the molecules undergo freezing temperatures, they slow down, causing the balloon to shrink.
In this experiment, we will be demonstrating Gay-Lussac's law, which the formula is pressure 1 over temperature 1 equals pressure 2 over temperature 2. Our materials will be tongs, a soda can, a bowl of ice water, a thermometer, and a pan over a stove.
So for this experiment, we poured some water into the can. We're then going to heat it up on the skillet until we see steam coming out of the bottle. Then when we see the steam coming out of the bottle, we're going to take the temperature. We're then quickly going to dump in the ice water and see what happens. Alright, now that the water is boiling and we've taken the measure, you can see that it is a whopping 192.5 degrees. Let's hurry up and do this experiment and see what happens. Okay, ready? 3, 2, 1.
Now that we see the can was crushed when we took it from the hot to the cold, we will look at the temperature of the ice water, and you can see that it's 1.3 degrees Celsius. We'll look at Ben's barometer, and we see that the pressure is 1.00459 atm. This experiment, we had the equation P1 over T1 equals to P2 over T2. So we plugged in the pressure 1, which was 1.0046 atm, over the temperature 2, which was 192.5 degrees Celsius, which is 465.5 Kelvin. And then the pressure 2 we didn't know, so that's going to be our X. And then our temperature 2, which was the temperature of the ice water, was 1.3 degrees Celsius, which equals 274.3 Kelvin. Once we did the math, we find our new pressure to be 0.592 atm.
Thanks for watching.